day, Acute Angels. Welcome to a new learning episode. I am Sir Joshua Q. Santos, your teacher for Grade 8 Mathematics. Before we start today's lesson, kindly prepare your self-learning module or your math book, pen and paper to write your answer as we progress with our discussion. And most importantly, look for a place in your home where you feel safe and comfortable. You may also comment or ask questions at the comment section. In this lesson, I will be guiding you in this week 7 lesson for the quarter 4 of grade 8 mathematics. At the end of this lesson, you were expected to count the number of occurrences of an outcome in an experiment using table, tree diagram, systematic listing, and fundamental counting principle. In the previous episode, you have learned about experiment, outcome, sample space, and event. So before we proceed with our topic, let us have a short review about the previous lesson. Please be reminded that you may comment or ask questions at the comment section. Let us begin. For the instruction, list the elements of the sample space or event in each of the given statement. Again, for the instruction, list the elements of the sample space or event in each of the given statement. Are you ready, grade 8? I think you are ready. Let's start with number 1, flipping a coin. You have 5 seconds to answer. Go! You are correct. The elements of the sample space are head and tail. In flipping a coin, there's only 2 possible outcomes. It's either a head or a tail. For number 2, rolling a die. You have 5 seconds to type in your answer. You are right. The sample space consists of the elements 1, 2, 3, 4, 5, and 6. A regular die has 6 faces, and the faces are numbered from 1 to 6, using dots to represent the numbers. It seems that you are doing a good job with your lessons. Let's have number 3, selecting vowels in the alphabet letters. Your timer starts now. That's great! The elements of the event are A, E, I, O, and U. Way to go, grade 8 learners! For this question, we have choosing an even number from 1 to 15 at random. You have 5 seconds to answer. Brilliant! The event consists of the elements 2, 4, 6, 8, 10, 12, and 14. An even number is a number which is divisible by 2. Good job, grade 8 learners! And for the last question, choosing a primary color of the rainbow at random. Your 5 seconds starts now. You are right. The elements of the event are red, yellow, and blue. Very good. With the excellent performance you did, I guess we are now ready to discover the next lesson. In every experiment, our task is to look for all the possible outcomes. We tend to list them one by one, or we use different strategies and techniques to find all of them. Just like in our review, flipping a coin, it is easy to identify the possible outcomes. We all know that a coin has only 2 outcomes. It's either a head or a tail. In rolling a die, we already know that it has 6 possible outcomes because it has 6 faces that numbered from 1 to 6. Even if we encounter such event like choosing an even number from 1 to 15 at random, being familiar with the word even number, I am 100% sure that you will find all the possible outcomes by finding all the even numbers from 1 to 15 with divisible by 2. Upon listing them one by one, we get 7 possible outcomes, and they are 2, 4, 6, 8, 10, 12, and 14. If an experiment is as simple as the ones that we are considered so far, getting the sample space or event is very easy. However, if the experiment is a little more complex, such as having a greater number of possible outcomes, then you need to use more systematic way of finding the sample space or event to make sure that all possible outcomes are listed. So for today's lesson, I will teach you how to count occurrences of an outcome in an experiment using table, tree diagram, systematic listing, and fundamental counting principle. Okay, let's proceed with the examples I prepared for you. Consider this experiment: flipping a coin and then rolling a die. What are the possible outcomes and how many outcomes are there in this experiment? This time, it's a little bit more difficult than the previous one. It's just like a combination of two experiments: flip a coin, then roll a die. So we expect a lot of outcomes here. It's better to use a more systematic way to avoid mistakes. Let's start using table to find the possible outcomes. Let's define first table. A table is a chart that organizes information in rows and columns. We can write the experiment in tabular form by labeling the rows and columns. Let's start with the rows by labeling them as the attempts in flipping a coin. And the possible outcomes here are head or tail. On the other hand, the columns will be labeled as the attempts in rolling a die. And the possible outcomes here are numbers from 1 to 6. Now, we completed the labels of the table. Let's start writing the outcomes. This table is just like the multiplication table, starting from the first row, which is head moving sideward, and then the first column, which is number 1, moving downward. The square where the two meet gives one of the outcomes. In this attempt, we get head and number 1. Let's try to find another outcome. Following the same way, moving head sideward, this time the second column, which is number 2, moves downward. In this attempt, we get an outcome of head and number 2. Next, let's find the third one. Moves head sideward, and then this time the third column, which is number 3, moves downward. In this attempt, we get an outcome of head and number 3. If we look closely to the outcomes we get, they follow the same pattern. It's simply combining the head and the following number. We can say that the outcomes in the next square of the table are head and number 4, head and number 5, and head and number 6. On the other hand, if we flip a coin and get a tail, we can use the second row to find the other outcomes. So we follow the same pattern, but this time, we use the second row, which is the tail, combining it to the attempts in each column. Let's start with the tail moving sideward. And then the first column, which is number 1, moves downward. In this attempt, we get an outcome of tail and number 1. Let's continue. Let's find the next outcome. Move the tail sideward, and then this time the second column, which is number 2, moves downward. The result in these outcomes is tail and number 2. To less the time in finding the other outcomes, let's use the pattern. Just combine tail with the number in every column. Here, we can get the outcomes tail and number 3, tail and number 4, tail and number 5, and last one, tail and number 6. Now, you can see in this table all the possible outcomes in this experiment. Counting all these possible outcomes, we can now conclude that the possible outcomes in flipping a coin and then rolling a die is 12. Did you get it? Did you find this method useful? Very good, grade 8 learners. But for some, if your answer is no, maybe this next systematic way will fit on you, or will take it as easy one to use in counting the occurrences of an outcome in an experiment. I'll introduce to you the use of tree diagram. A tree diagram is simply a way of representing a sequence of events. It uses branches to organize information from the start to the end of a single trial of an experiment. To better understand the use of tree diagram, let's have an example. Let's use again the same experiment. Flipping a coin, then rolling a die. Let's see if we get the same outcomes. Let's have a tree diagram. From the leftmost point, you see two branches representing the first phase of the experiment, which is the flipping a coin. There are two branches because there are only two possible results in flipping a coin, getting a head or getting a tail. Notice how the branches are labeled. Since the first phase of the experiment is done, it is followed by rolling a die, which is the second phase of the experiment. Now, the tree branches out further. The branches that belong to the same phase of the experiment are purposely aligned so that it will be easier to make sense of the diagram. In this figure, you can clearly see the first phase, flipping a coin, forming the first column, and the second phase, rolling a die, forming the second column. In this particular tree diagram, if you create a path from left to right by tracing through the branches, you can form 12 paths. The first path is head end number 1, followed by head end number 2, then head end number 3. Next is head end number 4. The fifth path is head end number 5. And last one, for the branches of head, is head end number 6. For the branches of tail, we have tail end number 1, tail end number 2, tail end number 3, tail end number 4, tail end number 5, and last one, tail end number 6. These 12 paths, in fact, make up the outcomes of this experiment. Counting all these possible outcomes, we can now conclude that the possible outcomes in flipping a coin and then rolling a die is 12. Did you get it, grade 8 learners? Very good. This time, let us discuss the other two ways in counting occurrences of an outcome in an experiment. Let us now move on to systematic listing. Outcomes for an event can be listed in an organized or systematic way to make sure that none of the possible outcomes are missed out. To better understand this method, let's have an example. Here's the experiment. Suppose a shopping mall has 4 doors, namely door A, door B, door C, and door D. In how many ways can a customer enter and leave the shopping mall? List all the possible ways of entering and leaving the mall by using systematic listing. Again, suppose a shopping mall has 4 doors, namely door A, door B, door C, and door D. In how many ways can a customer enter and leave the shopping mall? List all the possible ways of entering and leaving the mall by using systematic listing. So we need to find first all the possible outcomes to identify how many outcomes are there. In this experiment, we will use systematic listing. Of course, from the word itself, we will list all the possible outcomes in a systematic way. So here, when we start with door A, partnering it with the 4 exit doors, so we have door A and A, door A and B, door A and C, and last, door A and D. Excellent. Again, careful on writing the outcomes. Do it in a systematic way to avoid mistakes. Let's proceed to the other outcomes. Following the same procedure, partnering the entrance doors with the exit doors, listing them one by one, and now we have door B and A, door B and B, door B and C, and last one, door B and D. Next, we have door C and A, door C and B, door C and C, and last one, door C and D. Lastly, for door D, we have door D and A, door D and B, door D and C, and last one, door D and D. And we have a total of 16 possible outcomes. We can now conclude that a customer can enter and leave the shopping mall with 16 possible ways. Very good, grade 8 learners. And for our last way of counting occurrences of an outcome in an experiment, we have fundamental counting principle. It is a rule used to count the total number of possible outcomes in a situation. It states that if there are n ways of doing something and m ways of doing another thing after that, then there are n times m ways to perform both of these actions. In other words, there are n times m different ways to do both actions. In this way, you don't need to list all the possible outcomes to count the total number of outcomes. You just need to follow the rule by multiplying the number of elements of the first and second event. And the product of it is the total number of outcomes. Let's have an example to better understand this method. We will use the same example in systematic listing, but this time we will count the total number of outcomes using fundamental counting principle. Let us find how many outcomes are there in this experiment. Let's start with the labels of the events. We have entrance door and exit doors, and their product is the total number of possible outcomes. Next, simply write how many elements are there in each event. In entrance door, we have 4, and in exit doors, we have also 4. Multiplying 4 by 4, we have total of 16 possible outcomes. It is the same answer in systematic listing. Did you get it, grade 8 learners? Very good. If you are asked to count the total number of outcomes, this is the quickest way to find the answer. But if you ask to find all the possible outcomes, it's better to use table, tree diagram, and systematic listing. Take note that even if we use table, tree diagram, systematic listing, or fundamental counting principle, we can get the same answer as long as you know how to use these methods. Even if you go back on your traditional way of finding and counting the outcomes, such as attempting again and again, you will get the same answers. But in these new techniques, it saves a lot of time. Which is more convenient for you? Using table, using tree diagram, a systematic listing, or fundamental counting principle? Excellent! Now that you are really familiar with the use of these new techniques, let's have another example. You can use whatever method you like as long as you count the total number of outcomes. Let's see if you really understand the lesson. Here's the example. Yuri's Cafe serves 2 desserts, a cake and a pie. They also serves 3 beverages, coffee, tea, and juice. Suppose you choose 1 dessert and 1 beverage. How many possible outcomes are there? Again, Yuri's Cafe serves 2 desserts, a cake and a pie. They also serve 3 beverages, coffee, tea, and juice. Suppose you choose 1 dessert and 1 beverage. How many possible outcomes are there? You have 10 seconds to answer. Go! Time's up. Let's start with the table. Let the row represent the desserts, and the columns represent the beverages. Upon crossing the rows and columns, these are the possible combination of desserts and beverages: cake and coffee, cake and tea, cake and juice, pie and coffee, pie and tea, and last one, pie and juice. Next, let us show the answer using tree diagram. We can create 6 paths based from the given. And these are cake and coffee, cake and tea, cake and juice, pie and coffee, pie and tea, and last one, pie and juice. The same answer with the table. Even if we use systematic listing, we will get the same answer. Listing them one by one, we have cake and coffee, cake and tea, cake and juice, pie and coffee, pie and tea, and last one, pie and juice. And of course, last but not the least, fundamental counting principle. Writing the number of elements in each event. In desserts, we have 2, and in beverages, we have 3. Multiplying 2 by 3, the product is 6. What method did you use? Excellent. Did you get the same answer? Very good, grade 8 learners. Again, always remember, if you encounter an experiment which is a little more complex, such as having a greater number of possible outcomes, don't forget to use these methods: table, tree diagram, systematic listing, and fundamental counting principle. A more systematic way of finding the sample space or event to make sure that all possible outcomes are listed. Now that you are familiar with the use of table, tree diagram, systematic listing, and fundamental counting principle, it's time to check your progress. Let us now answer a short quiz to see what you have learned in our lesson for today. Are you ready, grade 8 learners? I know you are always ready. Again, you may type your answer on the comment section. Here's the instruction for your short quiz. Identify the number of outcomes in each experiment. Again, identify the number of outcomes in each experiment. Let's start with number 1. Kim loves ice cream. She has the option of vanilla, chocolate, or strawberry ice cream. And she has different toppings to put on her ice cream cone. If she has sprinkles, hot fudge, marshmallow, and nuts to choose from, how many different ice cream cones can she create with those toppings? Use table to count the total number of outcomes. For question number 2, a new restaurant has opened and they offer lunch combos for 25 pesos. With the combo meal, you get 1 sandwich and 1 drink. If the choices are egg, chicken, or hot dog sandwich, and juice or soda, how many lunch combos of sandwich and drink can you avail in this offer? Use tree diagram to count the total number of outcomes. Next, for number 3, Cardo wants to buy a monitor and a CPU to complete his computer showcase from a gun prize in a raffle draw. He can choose from 5 monitors and 1 from 3 CPUs. Determine the number of possible sets that Cardo can choose from. Use systematic listing to count the total number of outcomes. And last one, Mr. Cruz loves to read books. He has 4 books of Lord of the Rings and 7 books of Harry Potter. He can finish 2 books in a day. How many possible outcomes can he read 1 Lord of the Rings book and 1 Harry Potter book in a day? Use fundamental counting principle to count the total number of outcomes. You may take a screenshot of our quiz, answer the following, and don't forget to send your answers to your respective math teacher. That is all for now. I hope you enjoy our learning episode for today. Again, this is Sir Joshua Q. Santos, your grade 8 mathematics teacher. Until next time, have a nice day, be safe, and God bless us all.